Terry, what you working on?
I'm working on an Ampeg amp. I work on amps every weekend, but this weekend, as I've been working on this amp, I've been listening to this new Paul McCartney CD, the Egypt Station. I gotta tell you guys, if you love Paul McCartney, you have got to get this CD. This is Paul McCartney. It's like Paul McCartney Ram all over again, all right? You'll love it. It's Terry D-Lab. This weekend on the bench, I have a reissue Ampeg Reverb Rocket amplifier with no output. The guy had some 6L6s that he believed were bad. He bought some new ones, put it in, still no output. Let's see what's going on. Alright, we'll flip on the Ampeg. See if we have any indications of life. 6L6s are lighting up. I'll turn on standby, see if we get any hiss. Here's my master. Absolutely nothing, just like he said. So we'll turn off the standby and carefully we'll get in here and measure the plate voltages. So that's pin 3. Okay. 436 volts on that guy. And the same on that one. Now let's go to pin 4 and see if we got our screen. I don't want to electrocute myself here. No screen. So there's no reason to even check that one. You can see the screen resistors, these 470 ohm resistors. I can get right on top of that lead. I've got nothing. But to get to that back lead, turn off the standby. I'll have to put a different type of probe on where I can reach around. So let me do that and we'll cut back. Alright, now I've got a probe hooked on to the back side of that resistor. Turn my standby back on. You can see we still have nothing. Okay? So, more than likely we got something up in the power supply area that's bad. So if you take a look at your schematic, you'll see that this 470 and this 470 have a trace running between them on the back side, and they end up going over into this area of the power supply. There's some 10K 2-watt resistors here. So we'll go up here and see if we have that screen voltage. If not, you trace it back. It goes to this 470 ohm resistor, which is a 5-watter, and that is connected to the plate voltage, and we know we have plate voltage. So let's check this. So take a look at R43 on your schematic. That's where I'm connected right now, and there should be about 330 volts there, they say. Okay, here's the other side of it. Nothing. Then remember, it goes over here to this 470 ohm resistor. I have nothing. And on the other side, it's going to the plate voltage. And look at there, 434 volts. So obviously this resistor is open, or you got some humongous short over here, but if we had that, we'd probably see some smoke. So let's jump in another resistor and see if the amp comes to life. So be very cautious if you attempt this, because what you're going to do is you're going to bring about 430 volts on top of your cabinet, right? So I've jumped in another 470 ohm resistor, 5-watt, across what we believe is an open resistor, and I've got my meter monitoring that screen voltage off of R43, which would be going to the output tubes. Turn on the standby. Now obviously if there's a short, your new resistor up here is going to start smoking, right? So that's what we need to check. Here we go. Look at there. Set about 330 on the schematic. That's what we got. And if you listen, got some hum, a little hiss. She's alive. Good sign. So obviously that resistor is going to have to be changed out. And since it's on a circuit board, you have to remove everything to get it out of there, right? But before I do that, I'm going to put this thing on a scope. Take a look at the signal, make sure that this amp doesn't need anything else. For your reference, I'll cut to the schematic. So that screen circuit we're looking at, there's pin 4 of each of the 6L6s. There's those two 470 ohm resistors I showed you with a common tied here, through R46, which was another 470 ohm 5-watt resistor. That was the one that we actually found that was bad. That goes into the plate circuit, so it's grabbing this high voltage going through that resistor, feeds the screens, then it comes up through that 10K I showed you, which is R43, and it goes on its way to the preamp circuit. Alright, we still have our jumped in resistor, and now I have an audio generator hooked up to the input. Turn standby on. Oh, look at that. Let's take a look at the scope. Good looking sine wave. So that's a good sign. Now this also has a channel select. Ooh. So we got nothing when we select the other channel. Whoop. You hear that? Hey, this thing's got something going on. A little clickety-doo-dah. I betcha. We got us a connection issue. Oh yeah. Right up there. Alright, we're gonna kill it. So these jacks, if you look up here, are notorious for either bad solder connections where they mate to the board, or they become dirty and corroded and cause intermittent operation of channel switching. So I'm sure that's what we got. So looks like we have two things to correct on the amp. So I'm going to drop out the main circuit board. There's some screws here you can see, and then we have to take off all the knobs, and there's going to be some nuts underneath of those. I should be able to drop the board, flip it back, change the parts, check these jacks, either bad connections up there, or we'll put in some new jacks and that should solve it. So one thing that you'll run across on some of these new reissue amps, when you're taking off the knobs, you'll find that some of them don't want to pull off. If you use excess force, you'll bust this little shaft right off the pot and you're going to be miserable. So I have a couple here that are in that situation, so I take a little WD-40, get back behind, spray it in there, and let it weep up into those splines. Okay? Should probably do this either way, to tell you the truth. Makes removal of the knobs much easier and lessens the chance of damaging them. Alright, so I was able to get all the knobs off. They still have a little bit of WD on them. When you go to reinstall your knobs, take a little bit of that oil and put it on these shafts before you slide the knob back on, because you can also damage these pots by having too much force pushing into them, and it'll actually crack the carbon behind or deform the pot, and then you get to change it. Alright, I've got the board loose. Be very careful of these ribbon cables back here. They're thin and they're easily damaged. Okay, so I'm able to flip this guy up now. I'm going to give it a good inspection, change that resistor, and take a look at these jacks. So to remove that resistor, I'm just going to take some long nose, get down there and grab a lead, support this guy with my finger, keep that lead, and pull him up through. So I got one side loose, so I can stand him up on his end now. And he should pop right out. There's a little adhesive on it, but there it is. For the fun of it, we can ohm it out on my meter right there. Our 2K scale. You can see there's nothing. Here's our new 470 resistor, and there she is. Good to go. Let's get it in. New resistor is in place. Installation's pretty much the reverse of pulling it out. Just get yourself a... Whoops, that one looked good. The bigger the glob, the better the job for D-Lab, huh? Anyway, she's in. Now let's check out those jacks. So it's not very visible on video, but there are some hairline cracks where these terminals meet the pads. So I'm going to resolder these and I'll buzz them out with a meter, and hopefully they measure good and we don't have to change those two. So you can pretty much just heat these guys, just touch them up. probably all it is. It's the typical problem with any circuit board based amp. They grow bad connections. Alright, so we'll check the contacts. You just go across here and you want to see continuity. Okay. Now these middle jacks are not used. Doesn't appear. I don't see a trace going to it. Maybe I'm wrong. We'll check it anyway. Yep. So you just go across these jacks and make sure you got continuity. If you do, the jack's fine. Alright, the board looks good. Now before I reinstall the circuit board, you see all this grunge. Now is a really good time to wipe down that panel. Make your customer happy when he sees a little bit of a shine rather than an old cobbled up mess. So once again, be super careful when you're getting that circuit board back into place. Make sure that everything lines up, because if you get something out of place and you apply pressure, you can easily damage especially these pots. So I noticed that the original lamp in here kind of melted itself to death. Okay, so there's no reason to put something like that back into this amp. Where this hole is, I noticed, if you look inside, there's plenty of room to put in a real power jewel. Okay, so I'm going to drill this out slightly. We'll put in a nice glass jewel with a replaceable bulb. I think the guy would be thrilled. Alright, good old LP1 is installed. You can see I had plenty of room. I needed something for an insulator, so I used one of my business cards, right? Okay, so it's wired in to the original 6-volt source. Let's fire it up. Whammo bammo. Now he has a vintage glass jewel on his Ampeg. I flowed in a little bit of adhesive where the original was using E6000. You guys ask about this all the time. This is what I use. Alright, so here we go. Final test. I got the audio generator hooked back up. I'm in channel select position 1. So that works with the gain control. I'm going to go to channel 2. That appears to work with the volume control and not the gain control. So all looks well. I think we got her. Well, there you have it. The Ampeg lives again. Now normally I don't like to work on these PC board based amps. However, I never had an opportunity to work on this model. So that's why it's here in D-Lab. And you know what? It really wasn't all that bad. This is much simpler than working on the new Fenders. Sorry Fender, the Ampeg's good to go. Hope you liked it.